Okay, let's get started. Hi there, I'm Z, and yeah, I'm here to learn about and share my learning about AI testing. Well, it's a big task for me because first of all, I'm not really familiar with the whole concept in a really deep understanding level. So, yeah, as maybe you're still or already following me on LinkedIn, I started to get posting about my journey and my path, and I really hope that you will follow, and you're already following all of my things. Well, maybe it's enough for me, and let's do about something regarding the topic for today, which is the performance metrics of machine learning models. Yeah, which is my plan is to start with pretty basic stuff in regards of getting a whole picture about the whole concept and getting some metrics out of something, because you most probably know because you're following me on LinkedIn that I studied the EEST QB syllabus for AI tester, and there are several concepts and several theories, and I started to learn and read about many things in this field, and yeah, I felt like that it's pretty much time to get something done. Yeah, and sharing the whole process and the whole thing with you. Yeah, I feel like, at least in my head, it was a great idea to share the whole process with you, and getting all knowledge and practices and any kind of knowledge related to that topic. Yeah, about the whole going live stuff is maybe. I hope it will work. Well, this live is it will be nearly 1 hour, but afterwards I will edit this video. Of course, I'm recording it, and I hope that it will turn out pretty much okay. I added the nasty part out of it. Yeah, so let's jump to the topic. So the topic is the machine learning model performance metrics, which is a quite broad and bit general topic, but it's a good starting point. We will revisit the supervised machine learning models, and if you saw some posts of mine on LinkedIn, then you most probably know that I already shared some of it about the machine learning model performance metrics. So let's share this with you. Yeah, so this is the little spreadsheet or table I made from the EEST QB syllabus about the machine learning performance metrics. And if you see, there's the really the supervised kind of machine learning models performance metrics. We will see the classification type of models and the regression type of models and these kind of metrics. So I hope it will fit in 1 hour, but let's see. It doesn't really matter if not, but yeah, let's see. For first, we will do some metrics or measurements, or getting some data set from the classification type, with checking with the whole confusion matrix, and afterwards, if we have some time left, there will be some regression models. Yeah. Maybe a few words about this confusion matrix. I get my homework done, so of course I made this table, so I get some concept about it. What is accuracy, what is precision, recall, and the F1 score. And yeah, this kind of ROC, AUC. Yeah, so let's be enough at that point that these will be the metrics, and afterwards we get some metrics out of a model, out of a data set and a model. Then we will check what these metrics really mean. Yeah, I have this kind of EEST QB syllabus, which is completely reachable to anybody. I will share the link in the edited video description after I have, and all this kind of stuff which I will show during this session. Yeah, so yeah, first let's see the machine learning overview, supervised learning, but I think it will be the best if you check performance metrics. Yes, pretty much. Yeah, the EEST-QB is really has a naming of the machine learning functional performance metrics, because it would like to distinguish between the performance itself as a classical testing theory performance, and it distinguishes with that kind of functional word. So we will have that. Yes, this is the section. Okay, let's keep it that in the background. And yeah, other aspect which I didn't tell you, that first I will use, and throughout my work I think it would be a bit dishonest if I just show you the code and how to do the stuff without really introducing or showing you or disclosing the information that I usually use ChatGPT for all my stuff, which is a bit of cheating, but I don't feel like, because I would like to learn. And of course, if I have some output from ChatGPT, I can test it, test it, and I can really check that if it's correct or not. But yeah, let's see what I've got also here. Yeah, some nice live streaming stuff. And here it is. Yeah, and the right hand side you see the good old ChatGPT in my account, pretty plain, pretty decent. And then on the left side already made a GitHub repo for this live pretty much, and the future lives, because I'm planning to do further lives as well. Yeah, but this is about the machine learning metrics. I will share the GitHub link or the repo for this repo as well. Yeah, so first that would be mainly the structure for this live and for, of course, the recorded video. Then I ask some help from ChatGPT that provides some example, and let's copy, and if it needed to be, I will modify some things in the code, and let's see what will happen if I followed the instructions. And after this one, we will visit a nice little site called Kaggle, which is known and popular in data science field, which is full of data sets, real life data sets mainly, but some synthetical ones. But we will we will use some real life data sets for the classification and for the regression problem as well. And let's see how this stuff learned with or with the help of ChatGPT works with that. So what we would like to do, dear Mr. ChatGPT, let's be polite and have some hi. Yeah, so I would like you to show me an example of supervised machine learning models, performance metrics. I would like to use Python for that purpose. let's input ChatGPT what metrics we would like to have for data, what for it, and what would like to include in that session. So please include these metrics in your example. Yeah, so let's be the confusion matrix, let's be the F1 score, and let's be the accuracy. Let's be that kind of guy, and yeah, we can basically have that recall kind of stuff, but let's be enough for that example, and we will ask ChatGPT to provide some example to visualize these metrics. Please also visualize these metrics. Let's see. Nice. Okay, of course I will just copy paste the code, but we will have some sense and some explanation, some understanding, because of course I need to understand this thingy. Nice. Okay. Yeah, I don't really have interest in reading the text it provided, but yeah, ChatGPT was so polite that it reminded me to install these packages. Nice one. But yeah, let's first create that little file. Let's name it as ChatGPT example regression.py. Okay, let's copy that code. Yeah, you may notice that I did not install these libraries, and yeah, Python just tell me why not. Yeah, but I will in a little moment. Yeah, all this stuff has been installed. Let's see. It's really import. Shame. Yeah. Maybe I should use some virtual environment in order to do that. Okay, I already installed the libraries, but yeah, I think I will have some virtual environment, yeah, to have that. So yeah, sorry, I will frequently mistype the Y and the Z because I have some kind of a Finnish keyboard, and I am pretty much used to the Hungarian layout and vice versa, and I'm really missing this kind of stuff. So yeah, let's be a bit uncreative about what would it be, the name of the virtual environment, and let's check and activate it. Yeah, with that. Yeah, and okay, and scripts and activate, and here we are, and let's install this stuff in the virtual environment. Yeah, and hopefully we will get all these packages installed. Yeah, as you may notice, I have some Windows machine here, but I'm working with Mac and Linux machines as well, so I'm not really familiar in my professional work with the Windows machine, even the terminal, but I will do my best. Okay, install. Come on. Yep. For example, that will be a part that will be edited out from the video, which will be uploaded. Maybe I should have thought that. Yeah. Before. Come on. Okay. Shush, little GitHub. Okay. Now I can really, yes, use this kind of nice one. All the warnings disappeared. Yeah, maybe I'm still a bit interested still about what it does. And yeah, it says the Skykit, we are using the scikit-learn as I see for that example, and the scikit-learn has some data sets, not really predefined, but it's a common data sets for model training or testing purposes. And one of these data set is the EEST data set for this example. And as the machine learning model it chooses is the random forest classifier. I'm not really familiar with the random forest, or to be honest, any of machine learning models, but I think it shouldn't matter. And if we would be interested, or the community will be interested about, then maybe we can think about and check what it is. Okay, so we have a data set, which is the iris data set. We have the machine learning model, which is the random forest classifier, because it is a classification problem. And well, if you're not familiar with the iris dataset, I'm pretty much heard of it at least. And this iris dataset is about the flower itself, so it has some data about the iris flower types based on the petal sizes, petal height, petal width, and the another little petal thing, which I don't know what is the name of. Yeah. Okay, they're splitting the data. Okay, let's see, and I will provide some explanations. Yeah, that's a really important disclaimer from my side, which should be said, but I don't really want to overemphasize it, that these sessions, these live sessions and the videos won't be lectures. So I don't really know. More or less I know what I'm doing, but I'm not completely an expert on the topic, and yeah, let's put it that way. But I have some knowledge, and with that some knowledge, of course, I will use this knowledge. I would like to do this most honest way to really get the gist of the learning stuff, but I don't really want to hide anything, because that's the fun part. I think it's the whole learning things and getting things done, even with ChatGPT, even with any other kind of forum, or I don't know, Stack Overflow stuff, or even the Kaggle examples, to get some things done, get some information out of it, have some face plants, and yeah, that's the whole thing. Disclaimer end. Okay, so yeah, maybe I will get this VS Code full screen, and let's get through all of this stuff. What is imported, this doesn't really matter, because yeah, it's the from the sklearn is the data set. From the train test split, I will talk about it a bit later. This random forest classifier and all of these matrix, yeah, this AUC is not really used, neither the NumPy and the pandas as well, because usually pandas and NumPy is imported in these kind of tasks when there is a actual data set which is not an inbuilt data set of these libraries, but for example a CSV file or that kind of file, and with pandas we can get it to a desired form to get this model this model can be trained based on that model. But yeah, it's not really used here. Let's see if it's really not used. Yeah, but anyway, there is an iris data set which is loaded. There's two values or two variables, which is the x and the y. This pretty much works like a function in that way, you know, for example from high school, you know the fx kind of functional values. So there is x as I hope it's a dependent variable, and the whole value is the y. So this is the stuff. So yeah, we have some kind of data from the iris data set, and we would like to classify it that if it's some kind of different species of the iris flower. This is the y, this is the outcome of the whole machine learning model. And yeah, yeah, it's a main concept maybe, but maybe you're aware of it, that all of this machine learning and AI technology is good at predicting stuff. So in supervised learning, we have some data set, and from the data set there should be the outcome of the outcome of the whole model included already in the table. So we have some kind of, I don't know, 20 information, 20 kind of information about the target variable, which in this case could be different species of the iris flower, and you have some 20 preliminary parameters which has been recorded. In this case is the size of the petals, and based on these 20 parameters there is an outcome already, which is a different or given species of the iris. And we have some 300, 500,000, 10,000 million data set or record in this data set, and based on this training data, the model finds some connections between the sizes, data, and how it is evaluated by the data set as well. So what value assigned for the whole parameter set. And when we try to utilize that model, we see how good is this model in predicting. In this case, predicting the species of iris just based on the measurements of the petals. Yeah. Okay. Well, yeah, ChatGPT told that way that it is a binary classification problem, which means that it is something or not something. In this case, Setosa is the species name, and it decides if it's a Setosa or it's not a Setosa. Okay, which do that way. Okay, and yeah, I told that which this train test split. What does it do? It's a common practice, as far as I learned, in machine learning models, that given a million record dataset, and this dataset is used for training the model. And for training the model, we don't have really any outcome. Training don't know how good is the training. We need to test that training itself, and the whole data set is split between training data and test data. The usual percentage is 3.2, which means 30% of the data, or in this case 20% of the data used as a test data set. So 80% of the data is used as training, used for the training, and 20% of the data is used for testing and evaluating the model itself, how good it is trained, how good it is to predict what is the species of the given flower. Yeah, so it's split and assign this 80% of the data to the X and the 80% of the data to the Y, and do the same. So we have some kind of X train. It's 80% of the X parameters and 20% of these X parameters, and same with the Y. Okay, it instantiates the random forest classifier and it fits the training data to the model and it predicts. Yeah, so it in this step, if you see it, yeah, in this step it fits the training data to the model, and now in this step we have some kind of prediction for the test variables. So we have a prediction for the 20 given parameters, but we don't provided information on what is the actual value of the species, what species are this parameter set represents. So this is what the model predicts by itself. Okay, predict on the test set and calculates these metrics which I given. So it's a confusion matrix, it's F1 score, the accuracy, the ROCAUC, and yeah, it's just really the curve itself. Okay, and it prints. Well, okay, I think we pretty much these steps are just plotting the plotting the values, or maybe the ROC curve, which I just asked ChatGPT to do. So let's execute and let's see what's done. Okay. Yeah, it's not that many data sets if you records in the data set, because you see there's a confusion matrix in here, and little it also printed out the F1 score accuracy, and it's not really interesting because it's 100% good training. I hope we will get better values for the real life example. But yeah, with this confusion matrix, what is this confusion matrix? Yeah, we could check maybe from the document, but yeah, I can explain it, or share my understanding with you, that this confusion matrix says so that what is the actual value, because we have that kind of information in the data set, that if it remember that 20% of the data set is used as test data, and it predicted the value of the species, but we didn't share the actual value with the model, value of the species with the model, and it's started to predict what it is. But the actual value means the actual value is these. So if it finds in the data set, in the test, from the test set, that 26 is not setosa, it is really classified properly, because it predicted as 26, and the actual value is really 26 of these records in the test data set is not setosa, it's a different kind of iris species, and it classified well because there is nothing in this field which is the false value, so the predicted pretty much correctly, and this predicted the set of the values as well. Okay. It's not really, and it's not really interesting. Come on, ChatGPT. Show me some not linear things. Linear things are boring, but it's easy to predict. Yeah, it's receiver operation characteristic, the ROC curve, which really means that what it is the relation between the false positive rate and the true positive rate. As I mentioned, the true positive is the what predicted as something, and what it is, the actual value, and the false positive is predicted as something, but actually not that thing. Yeah, that was that example. And my session has expired. Nice. Come on. Jeez. Okay. But why is that? Okay, doesn't really matter. Yeah, but I think I will relog with some email address. Yeah. Okay, so we get that. But let's complain a bit about the result it gives me, because yeah, it's a bit boring. Make it a bit interesting. The random forest, which was that? I think the random forest was the random forest classifier. The random forest classifier worked pretty well, but please provide me something, provide me an example of different data set and different model where the actual values of the prediction is not 100 or not 1.0. Yeah, you know, it is for demo. Really interested about what it does, but yeah, let's not push that session to a way that we starting to test the large language model itself, because it's a really different topic. And let's move on afterwards. It really doesn't really work. Okay, so the breast cancer, happy topic, Wisconsin dataset with support of vector machine model, which is a classifier. That's great. May not achieve perfect scores, making it interesting, for your demo. Nice. Let's see it. Nice one. Yeah, really. Misspelled that. GG. Example. Okay. Let's add another. Come on. Let's add another. ChatGPT example regression. Let's not name it as new or two or that kind of shady naming, but yes, let's name it after the models. Let's name it after support vector machine.py, and let's rename that as well for random forest. Okay, so okay, basically I really assume that these values are, or not the values, but the basic steps are the same. Yeah, because, and yeah, I'm pretty much okay with deleting these because not really used. VS Code helps identify these are not really used because it's a bit darker shade of that color. I remove it because it really bugs my mind. Okay, so yeah, it's support vector machine. Okay, it's loads the data set, split, not splits, but yeah, signs with the x and the target variable. Okay, it splits the data set. It instantiates the support vector machine, feeds the data, predicts the data, getting these metrics in place, and accuracy, ROC. Okay, then let's see what we got here. Jesus, I mean, okay, and ChatGPT, and not that. Ah, nice one. I really hope that we will have. Okay, nice. F1 score, the accuracy. Well, actually, these values are quite not bad because it's really high values. Yeah. By the way, let's see some. Yeah. What do we have here? What do we have here? Yeah, let's see side-by-side stuff. So let's see here and let's see there. Okay, I think it's pretty nice. So this is the document, ISTQB document, which is pretty much contains the information from these metrics, the confusion matrix. Yeah, so the true, positive, false, negative, true, negative values, they are, yeah, the table is a bit flipped in a way that in this axis they are predicted and this is the actual value, because it's a different kind of, because there's the predicted value and there's the actual values here represented. But yeah, I assume I wouldn't assume it, but yeah, I think the main concept of this data set, this breast cancer thing, there's some geometrics in the MRI and the CT picture, and there's some geometrical measurements of what is the size and what is the color and that kind of stuff, and it classified that if it's benign, which means it's not really harmful tumor, and that is a malignant, which is not really means a good thing. Yeah, but it's really important to have some kind of model, which is it can be useful for classifying these images, that if it's really bad or good, and how good is the prediction of the model, it's really necessary for the doctors, for example, could be necessary for the doctors to make every kind of prediction well on point, because it's really a matter of life and or death. Whew. Okay, so let's see the values here. Let's get back to a bit friendlier machine learning topic. So yeah, the values here, yeah, it's a bit flipped, but the actual values are here, and there is a positive kind of thing, which right now the positive outcome is the malignant, which is we would like to predict if it's really harmful. It could predict pretty much okay in that value, so the true positive values are great, and the true negative values are also great, which is a negative kind of stuff. Yeah, this is the negative stuff, but it has some kind of imperfection with predicting falsely that it is a harmful tumor in the picture, which is yeah, considering the whole concept, it's not the worst in a way that if it would be much worse that if it would be classified as or predicted as a benign one, and if it's a really a malignant one, but I think it's a really, no, it's the case, yeah, because it's the predicted value is benign in here, but the actual value is malignant. Okay, it's not good. It's really not good for that kind of thing, because the purpose of this model and this task to really get rid of these values, because it can be misleading and pretty much harmful. I mean the prediction as well, yeah. But this is the confusion matrix part of the whole concept. I mean the whole model and the whole model fitting on this data set. So actually the evaluation of and the meaning of this confusion matrix, that it could pretty much well in a manner that is what it predicted as harmful, it's really harmful. I mean all of these, because there is no value here which is predicted as harmful, but it's really not harmful. And the missing part, which is a really dangerous thing, that it is predicted some of these not harmful, which is really are. Even if these values are 90% or 95%, this can be really dangerous in that kind of utilization of the model. Okay, let's see what is the accuracy, what the accuracy value shows us, because I think that's the most simpler one. It's 93. In this case, the accuracy measures the percentage of all correct classifications. Well, the percentage of all correct classification means, of course, these. It can be calculated with these formula, and yeah, because it is really 93%, it means that these 11 is missing from the 100% from the accuracy. Okay, the next one is the F1 score. The F1 score, it's a harmonic mean of the precision and recall. What is precision and recall? And it's a different kind of question. Yeah, the precision, the proportion of positives, which is predicted correctly, and the recall, the proportion of the actual positives that were predicted correctly. Yeah, and basically the F1 score is an overall measure of all the accuracy, precision, and recall, and these three metrics, and it can be used, because I almost forgot that we have some kind of summarization of this stuff. Let's zoom in a bit. Yeah, when to use it. Yeah, so it's this F1 score, when we can use it when the class distribution is imbalanced and when the cost of false positive and false negatives is different. In this case, it's really different of the cost of false positive and false negatives, because these are the false negatives and false positive values, and these are really different, because having diagnoses, as I told you before several times, these have pretty much high cost, and these are not really, or of course this is also not a good thing to have that kind of false positive value, but yeah, this false negative is really bad for us, and the F1 score represents that represents the, it's a good metric for representing that imbalance, and when not to use when the data set is balanced and the cost of false positives and negatives are equal. Yeah, accuracy, if you see, it's not a really good measure. It tells us something about the model fit. Yeah, and what is the ROC AUC? When it's a model's ability to discriminate between positive and negative cases, and when to use it accordingly. It's a pretty nice summarization table. When there's a need to compare the performance of different classification models, especially when the class distribution is imbalanced. As we discussed, that it is the case. These are imbalanced, but let's close that. Where am I? This is the figure. Okay, we'll close that. Yeah, and this is the receiver operating characteristic. curve, and this is the actual curve for that model. Sorry, a little coughing. Yeah, but as you can see, it's a really near to the 100% true positive rate, which is pretty already still nice. Okay, then I think we should go towards to the real life. I mean, this is real life datasets as well, but integrated datasets. But let's see what's the working of the whole data importing stuff, and importing stuff works with the pandas library with the help of Kaggle, and finding some nice real life datasets on that, and maybe we can compare models as well. Okay, let's see, where is my browser? Here it is. Okay, so Kaggle. Yeah, nice. Yeah, I'm a bit cheating in a way that I also checked what's available on Kaggle. And if we are in that nice little topic of breast cancer, let's follow with the diabetics prediction. Oh, it's for logistics, sorry, the Parkinson's disease detection. Yeah, that would be. Yeah, because it's a classifier problem, and it's basically the same as the breast cancer thing, because in the Parkinson detection model, Parkinson detection is not an easy task in a way, but for just using the picture or the imagery of the whole procedure, but have some other values. As you see in Kaggle, you can also find the steps how to do stuff, how to visualize everything. Yes, and it uses several kind of models. It's nice to learn how to do that. I think it would be beneficial, yeah, because if you see with this kind of solution, there's models, which is a different kind of machine learning models, logistic regression, decision tree, random forest, whatever these mean, I don't know, but it clearly has different kind of values here. Okay, and it evaluates, have some classification report. Whoa, it's nice. Okay. Sorry for I'm not unmuting now. Okay, it's a nice one. This is the CSV files. Let's check what the guys do. Yeah, because I think that's the best learning method, that search for someone who can do the actual task we would like to learn, and let's if he or she shares this information, it's a good way to learn that. Yeah, it's reading the data. These are the features. Okay, split. It just prints the data. I think it's a clean data set. Define, plot the distributions. Yeah, it uses, okay, it uses several, it uses really the Seaborn heavily, Seaborn library. It instantiates the models in different kind of vein. Yes. Okay. Sounds nice. Let's do it. Okay, let me check. What is the time now? Ooh, okay, we have that. Okay. We don't have really much time for the regression. Not good, not good. But there's an idea. What if we can check the regression kind of stuff first? Yeah, and after the lives here, or maybe have some additional time in the live, but yeah, I'm not sure. 1 hour is 1 hour. I will do this Parkinson detection kind of stuff, another regression in GitHub, and you can reach it and find it. And after the edited video will be done, then it will be for you, and it will be available. Of course, these are available because you can use ChatGPT, and of course I will share the ChatGPT kind of stuff. But yeah, GitHub it seems professional in this case. Okay, let's check regression, I think, because maybe it have some other meetings and really would like to learn something, because we learned something in the classification model, and maybe we can have something for the regression as well. Okay, let's be polite once again. Who knows, maybe there's a people just reading what I'm reading. Yeah. Yeah, many thanks. Now I want to have the same example concept for a regression. Let's be more specific. Concept for a supervised machine learning regression problem. Let's see if it's enough context for ChatGPT. Yep, seems so. It's a random forest regressor, because random forest not only have classifier, but it has a regressor as well. The infamous California housing dataset. Yeah, you're pretty much lucky, because I heard of this kind of dataset, and it is about houses, or some kind of houses in California with a different kind of parameters, like the size or the garden size, the floors of the building, and number of rooms, the type of rooms, and the nearest supermarket, these kind of parameters. And this model tries to predict what would be a price for a house which is just put to the advertising page with a different kind of parameter set, and based on the pricing and the selling price, it will predict what would be the most possible selling price of that house. Yeah, let's check this stuff and let's see what is the values. Well, this session is turned to be a real ChatGPT session. Nice, but yeah, let's focus on what we are learning on that, how to use copy and pasting. ChatGPT example. For some reason I used regression previously. Okay, I will correct that a bit later. Regression, and it is a random forest actually, so I will rename that first, because it's not really a regression, it was classification, and this is also classification. Okay, and finally these are regression of the random forest. Nice. Okay, copy pasting at its best. Okay, nice. Let's just a sec. Okay. Okay. Yeah. Sorry. Okay, still would like to import this stuff, but not needed. Yeah, let's quickly. Yeah, many thanks for the comment. Ah, it warms my heart. Yeah, but let's get back to the regression, which is a random forest, and let's check the steps, and we will fit in 1 hour, just like that. Okay, let's see. I think the main concept is the same with getting the preliminary steps done. So importing the dataset itself, assigning the value of the x for a dataset, and let's assign the target of the to the target variable to the data target values. Split the dataset. Let's use it. It's a 20%. This really seems or feels a bit appropriate or more appropriate. Okay, so we have the split between the x and the y, and there is a random forest regressor instantiation, and it's the model fitting to x train, y train. Nice, the model has been fit, and it predicts now in that step. Yeah, and the metrics about the mean squared error, the mean absolute error, and the R2 score. Let's just check these, and what are these? Yeah, the mean squared error. Yeah, I think it would be the best just execute classification and regression. Okay. Yes. Is it happening? Is it? Yes. Oh, nice. Yeah, it really seems like nice fitting problem, because there is some predicted and actual values here, and this is the fit of the model. Okay, just let me check if we'll use a regressor, and yes, the features about various houses in California. Target variable is the median house value. Okay, let's have that. Okay, and what is the actual and predicted values? The actual values of, I would assume that is 1 million or 100,000, 200,000, that kind of values of the houses. What is the actual value? What are the predicted values? And it fits nearly a linear function to it. Okay, and let's see what are the values. So the mean squared error, the mean squared error is the average square difference between predicted and actual values, and it really means, if you have some knowledge on the regression kind of regression of the on a data set, that this is the prediction line, let's say so, and all of these dots difference between the actual between the predicted and the actual value has been counted and measured. The distance. It really means the geographical distance in this plot, for example. And it's the same for the mean absolute error as well. The mean squared error is really differs from the mean absolute error, that the absolute value is just actually measure the distance in the manner of x coordinates and y coordinates, and the mean squared error doesn't really care about and if it was less or more. So these values, when you're counting the mean, of course, it's when it's mean absolute error, it adds the negative and the positive values, and it can, but +1 and -1 is 0, and it doesn't have any meaning at most cases, but in some cases it's really useful when, for example, when we want simple and interpretable metric. But mean squared error, the distance is just really squared, because in this case it's all positive, and we calculate the mean of these squared distances between the regression line, or between the regression line and the actual or predicted value. So it seems like, if you would like to judge how good is this model, I would say that these values are pretty much okay values. It doesn't seem like it's really high values, just out of my head. Let's see. And after we have some summarization. Okay, what do you think are these metrics represents a good model performance in this case? Yeah, come on. Okay, lower values indicate better performance. Not kidding. Interpretation. Yeah. It's hard to scale of the target value such that the model's predictions are reasonably close to actual values. Yeah, because we have a scale, it just tells us we have a scale of 0 to 5, and the mean squared error, so that the distance between the actual and predicted values, and 0.25, which is not bad compared to the whole scale, which is 0 to 5. The mean absolute error is another kind of thing, and the r squared value, which means the variance. Yeah, variance in the house price is explained, and most of the variability is in the target variable. Okay, nice one. Yeah, I can. Yeah, well, we have some kind of distribution as well with the residual distributions. Yeah, the frequency and the residuals. Yeah, in predicting the values, the distance between the predicted actual variables and what is the frequency. Okay. Yeah, but the time's up, guys. So I think we can wrap this up a bit quickly. Yeah, so we have some nice data sets in Kaggle, which I think I will just share what I chose to be on the live, but maybe I can play with that a little bit. But of course I will share these. These are some nice examples, and you can try with those to check the metrics. And of course I will share this chat with ChatGPT and the files, what we've done with this. Yeah, so that was it. That was the first live. Many thanks. If you'd like it, but yeah, if you're not, pretty much please follow me on LinkedIn and on Twitter as well, and let's see what we can learn more. There's more posts to come. Usually you can maybe figure it out, there's posts in 3 posts most of the times in a week on LinkedIn, 5 posts on Twitter, so please follow on Twitter, AI Testing Quest. I'm run on LinkedIn as my name, which is Zoltán Tarkó. but you can find the LinkedIn and the Twitter link as well in the description of this live, and you will find the description under the edited video as well, which I plan to be make it on Monday, or I will upload it on Monday, maybe Tuesday, let's see. And yeah, that's pretty much it. Many thanks for joining, and I really don't mind if you share the YouTube video when it will be uploaded, and share the information that, hey, there's a guy who tries to learn something about testing AI or testing machine learning models, and pretty much enthusiastic, even so that he could really do this YouTube live despite of the heavy anxiety before that. But yeah, pretty much liked it. Yeah, so thanks for joining. See you.